Welcome, geometry students. Today we're going to be talking about the next target, which is to use angle pairs, specifically vertical angles, complementary angles, and supplementary angles, in order to identify and solve problems formed by intersecting lines. This is also including perpendicular lines. So before we begin, it's important that we understand the different possible angle relationships that could occur. First of all, complementary angles are two angles that add to be 90 degrees. So we might have adjacent complementary angles, and adjacent just means touching. So for example, it might be those two angles that add to be that 90 degree angle. So we could have adjacent right angles, or we could have non-adjacent complementary angles, and that would look something like this. So suppose we have a 40 degree angle and a 50 degree angle. Those two are still complementary even though they're not attached because they add to be 90 degrees. So again, the definition for complementary angles is simply two angles that add to be 90 degrees. Supplementary angles is very similar, only their sum would be 180 degrees. So supplementary angles are two angles that add to 180 degrees. Once again, we could have adjacent supplementary angles and we can have non-adjacent supplementary angles. A linear pair is a pair of angles that make a line. So it's called a linear standing for line, and pair standing for two angles. So essentially what this means is it's required to be a pair of adjacent angles, so they must be attached, and they must be supplementary. That's how the line is created, by making a total of 180 degrees. So if I have a line and I draw in another ray, I have my second angle. So angles 1 and 2 are considered a linear pair. So linear pair and supplementary angles, you might be wondering what the difference are. The difference is supplementary angles can be adjacent or non-adjacent, but a linear pair must be adjacent, whereas supplementary angles do not need to be. But the commonality between those two is that they both add to be 180 degrees. So it's two angles that would add to be 180 degrees. Next is adjacent angles. So we've been using that term quite a bit. Let's go ahead and look at a definition. Adjacent angles are two angles that have a common or shared vertex and a side, but they do not overlap. So you can have adjacent angles that aren't complementary and aren't supplementary, but still fit that definition. So for example, these two angles may not have a special relationship of adding to be 90 or 180 degrees, but they're still adjacent angles because they share that common vertex and the common side length here. And there's no overlapping going on. Vertical angles. Vertical angles are two angles opposite each other created when two lines intersect. I want you to make a note about vertical angles. Vertical angles are always congruent, which means they have the same measure. So let's look at this definition. So we have two angles opposite each other created when two lines intersect. So here's my first line. Here's my second line. Well, if you notice that creation or that intersection creates 4 angles. 1, 2, 3, and 4. And what we're going to do is look at which of those are vertical angles. Well, angle 1 and angle 3 are the angles opposite each other. So that's a vertical angle pair. And we noted that vertical angles are always congruent. So angle 1 would be congruent to angle 3. Likewise, angle 2 is opposite angle 4. So angle 2 and angle 4 make up a vertical angle pair. Therefore, angle 2 will be congruent to angle 4. If you look at this, we also have other relationships going on. For example, angles 1 and 2 would be supplementary because they form a line. They're also a linear pair. And we could repeat that. Angles 2 and 3 are supplementary and form a linear pair. Angles 3 and 4 and so forth. So there's a lot of relationships there going on. These different angle relationships are very important because they're going to help us to find unknown information in different situations. So you really want to make sure you understand these definitions. If there's one you're not sure about, please make a note of that in your annotations. All right, example 1. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. All right, so we know that complementary angles and supplementary angles add to either be 90 or 180. The way I remember the difference is complementary, the letter C comes in the alphabet before the letter S. So C goes with the smaller degree measure, and the letter that comes later in the alphabet goes with the larger degree measure. So if you're kind of unsure about which one's adding to be 90 and which one's adding to be 180, that might be a helpful tool in remembering. So complementary angles. If we look at these different scenarios, the complementary angles would be the 2 angles that add to be 90 degrees. Well, here, this 52 degree angle and the 38 degree angle together would add to be 90 degrees. So angle ABD and angle BDC are complementary angles. Now, one thing I want to make a note of is when you look at this, I could have named angle ABD by just calling it angle B. That's acceptable because it's the only angle around that vertex. However, I cannot name angle BDC angle D. Here's why. If I look at vertex D, I have several angles occurring or created around vertex D. I have this angle here, and I have this angle here. I also have the sum of those two, which would be angle CDE. So you want to be really careful that when you're naming angles, that you use all 3 points that create that angle so that we're sure that we're naming the correct angle. All right, let's look at supplementary angles. I'm going to erase what's on my picture so that it's a little clearer to see. Supplementary angles are 2 angles that add to be 180 degrees. So if we look at our picture, the 2 angles that add to be 180 degrees would be this 52 degree angle and the 128 degree angle. So angle ABD is supplementary to angle, again, I name it with 3 letters, and my vertex has to be in the middle. So since this is the angle I'm naming, I can go in either order. I can say angle BDE or angle EDB. It does not matter as long as the vertex is in the center here. Finally, adjacent angles are angles that share a vertex and share a side. Well, the 2 angles that do that are centered at vertex D, so it's these 2 angles. So I'm going to walk myself around the angle again. It's angle CDB, or the reverse of that. I could have also named that angle BDC, and angle BDE. Key is that that vertex is always in the center. All right, let's continue on. Example 2 says to find the measure of complements and supplements. Well, we're given that angle 1 is a complement of angle 2. This is a really important word, and it's going to tell us what to do. So we want to pay attention to our key vocabulary in our problems. That's really important in geometry. So angle 1 is a complement of angle 2. Angle 2 is 57 degrees. We need to find angle 1. Well, the first thing I would do is create an equation showing the relationship of complementary. Well, angle 1 is told to be complementary to angle 2. Therefore, they must add to be 90 degrees. So, it would be true that angle 1 plus angle 2 is 90 degrees. We also know that angle 2 is 57 degrees. So I'm going to use substitution. That's a property we heard a little earlier in the unit. Substitution to replace angle 2 with what we know it to be, or in this case 57 degrees. Now that we have this equation, all we need to do is solve. So we're going to isolate angle 1 by subtracting 57 degrees from both sides, and we find that angle 1 is 33 degrees. Any other measure, and these two angles would not be complements. Alright, example 3 says to use angle relationships. Two angles form a linear pair. So the key here is linear pair. Pair means two angles, and linear means that those two angles form a line. So in other words, those two angles are going to be supplementary, or adding to be 180 degrees. It says the measure of one angle is 5 times the measure of the other. In my opinion, I would start with a picture here. So I have two angles forming a line. Those two angles make a linear pair. But it says one of them is 5 times the measure of the other. So if I let this smaller angle be x, this second angle must be 5 times as large, or equivalent to 5x. Now we have our picture. We need to find the measure of both of these angles. Well, I'm going to use what I know about a linear pair to make an equation. I know that the angles in a linear pair should add to be 180. So 5x added with x equals 180 degrees. Now I'm going to solve this using my algebra to find x. Well, 5x adds with x to make 6x. And when I divide by 6, I find that x is 30. Well, if x is 30, then that means one of my angles is 30 degrees. So the angles are 30 degrees. And the other angle must be 5 times x, or 5 times 30, which is 150 degrees. So the angles are 30 degrees and 150 degrees in this situation. Example 4 says to identify angle pairs. Identify all of the linear pairs and all of the vertical angles in the figure. Well, if we look at this situation, a linear pair is a pair of angles that makes a line. So my two situations where that occurs is angle 1 and angle 2 are two angles that make a line. Likewise, angle 2 and angle 3 are also a linear pair. However, angles such as angles 1 and 5 are not a linear pair. They're adjacent, but they don't add to be 180 degrees, so that would not work. Vertical angles are angles created by two lines intersecting, and they're the angles opposite. So in this case, angle 1 and angle 3 are vertical angles. Now, another thing that we talked about was a special note, and it's that vertical angles are always congruent. So you should be aware that angle 1 will be congruent to angle 3. Now, angle 2 is not vertical to any other angle, because angle 2 would not work with angle 4, and it would not work with angle 5. It would work with that entire sum, but that's not one angle. So we don't have a vertical angle pair there. Go ahead and try the You Try Now, and if you have questions, make a note of that in your packet, and we'll come back to see one another soon. Have a good day.